The Floyd-Warshall algorithm is a dynamic programming algorithm used to solve the all-pairs shortest path problem in a weighted graph with both positive and negative edge weights, but without negative cycles. The algorithm computes the shortest distances between every pair of vertices in the graph. I've considered here a simple weighted graph to explain the Floyd-Warshall algorithm. Firstly, construct the weight matrix and name it as A0. The entries in the weight matrix corresponds to the weights of the edges, edges between corresponding vertices. So in the weight matrix, the diagonal entries are 0, as there is no loop in this graph. Now, if there is no edge between any two pair of vertices, give the weight as infinity. Now, set up a matrix A1 as follows. Let the first row and the first column of A1 be the same as A0. So I have the first row and the first column of A1. I write them as it is, as A0. Now the diagonal elements are the same, so you keep them as 0. Now consider the other non-diagonal elements. We consider the minimum of the original weight and the sum of the weights via vertex 1. So the shortest path between 2 and 3 in this case is infinity. We consider the minimum of infinity and the path that is via 1, that is 2 plus 3, which is again infinity. So the minimum of infinity and infinity is infinity, which we write it here. We fill up the remaining non-diagonal elements in A1 as follows. Let us consider 2, 3. So we consider the minimum between infinity and the path via 1, that is 2 plus infinity. So the minimum of infinity and 2 plus infinity is infinity. So we write infinity here. Now let us look at 2, 4. We consider the minimum of this entry, which is 4, and 2 plus 5, which is 7. So the minimum of 4 and 7 is 4. So we write 4 here. Similarly, we now consider 3, 2. So we take the minimum of 1 and the sum of infinity and 3, which is infinity. So the minimum of 1 and infinity is 1. So we write 1 here. Let's look at 3, 4. So we take the minimum of infinity and the sum of infinity and 5, which is infinity. So we write infinity here. Similarly for 4, 2, we have infinity and the minimum of infinity and infinity plus 3, which is again infinity. So we write infinity here. Now for 4, 3, we take the minimum of 2 and infinity, which is 2. So we write down 2 here. So this completes the matrix A1. Now for A2, for matrix A2, we now fix the second row and the second column of A1. So the second row and the second column of A2 will be the same as that of A1. Again, all the diagonal entries are 0, just like in the previous case. For the other non-diagonal elements, we take firstly 1, 3. So we take the minimum of infinity and 3 plus infinity, which is infinity again. So we write infinity here. For 1, 4, we take the minimum of 5 and 3 plus 4, which is the minimum of 5 and 7, which is 5. For the next non-diagonal entry, 3, 1, we take the minimum of infinity and 1 plus 2. which is 3. So the minimum of infinity and 3 is 3. So we write down 3. For 3, 4, we take the minimum of infinity and 1 plus 4. So we take the minimum of infinity and 5, which is 5. For 4, 1, the minimum of infinity and 2 plus infinity, which is infinity. Again for 4, 3, the minimum of 2 and infinity and the minimum of 2 and infinity, which is 2. So this completes our A2 matrix. Now for A3, we fix the third row and the third column as it is, that is as A2. So we take the minimum of each weight with the path via vertex 3. So we repeat the same procedure to get A3, and finally we set for A4 the fourth row and the fourth column same as A3, and repeat the same procedure again to get the final matrix A4. Now this completes the stages, as there are 4 vertices. So A4 gives you the matrix that gives us the minimum path between every 2 vertices. So this is about the Floyd-Warshall algorithm. Thank you very much.